Welcome back. I'm glad you guys returned. We're now going to start the videos where we actually learn about chemistry, and we're going to go over the things that we're going to cover in class. But before we get started, I want to give you guys an overview about the concepts or things that we're going to learn about or talk about in Chapter 1. The first thing we're going to cover is what is chemistry. It is really hard to study something when you don't know what it is. And so we're going to just briefly describe what chemistry is. And then we're going to move into the scientific method. So how do scientists think? How does science get done? That's a very important thing for us to talk about. And then we're going to talk about matter. What it is, how we can classify it, how we can characterize it, what happens if it's mixed up. We're just going to talk about matter and why it matters to us. And then finally, we're going to talk about units. We're going to talk about what units we'll be using in the chemistry class. We'll talk about what we can do with those units, converting them from one to another. We'll also talk about some units that are made up when you combine two different types of units. Units are very important in this class. I will constantly remind you from time to time that there is no such thing as a naked number. The majority of students lose points on their exams and quizzes because they forget to put their unit or to put a unit on their number, thereby causing a naked number. So let's say I were to ask you, can I have 40? And of course the follow-up question to that is, well, 40 what? 40 grams? 40 liters? It makes a big difference when you don't have that unit. And so units are very, very important. The units we will be looking at in class are a combination between the SI system as well as the metric system. So we'll look at things like grams, meters, degrees Celsius, moles, we'll get to in Chapter 2. So those are the units that we should be familiarizing ourselves with if we're not used to using them. So what can we use units for? One of the things we can use units for is to describe how much of what we have. And not only how much, but we can convert it from one measurement to another. So let's say I have 1 kilogram of apples. I only have a customer that only buys grams of apples. And so I know I have a kilogram of apples. He only buys grams of apples. So how many grams of apples do I have in my 1 kilogram? There is a table in your book that details the change in unit caused by a prefix. So kilo is a prefix to gram. Well, kilo, so 1 kilogram, kilo means 1,000. And so we know that 1 kilogram is equal to 1,000 grams. So this unit conversion is relatively straightforward because we only have 1 kilogram of apples, and we want to know how many grams. So we know that we have 1,000 grams of apples. You will not be provided this information on an exam. How to convert between kilograms and grams, how to convert between milligrams and grams. You're required to know the number, what the prefix means, and then to do those conversions. Now, Obviously, I don't expect you guys to be perfect right now. That's not an expectation of mine. But with practice, we should be able to get a lot better at doing these simple conversions. Another type of conversion that we can do is a non-metric unit into a metric unit. So this comes from problem number 98 at the end of your textbook. And what it says is we have a 5-gallon container. And we want to know how the volume it will hold in centimeters cubed. Now, we look at that centimeter and we think, that's a length unit. That's not a volume unit like gallons is. And you would be absolutely correct. But when we add a cube to any measure of length, it now becomes volume. And so what we know, or what we can determine, is that 1 centimeter cubed is equal to 1 milliliter. And again, that is found in your book, found online. Again, that is one that we'll just kind of have to know off the top of our head. So, I'm going to show you how I usually solve problems that occur through unit or 4-unit conversions. I term it the railroad method. So what I do is I always start with what we know at the top left corner. That's a gallon. What we want is in the top right corner, or at least the unit of what we want is at the top right corner. And so now we have to go from gallons to centimeters cubed. So we need to find out what 1 gallon equals. 1 gallon equals 3.785 liters. You will not have to know these types of conversions for the exam. I will give them to you. I will give you the conversion between gallons and liters. I will give you the conversion of centimeters to inches. I will give you all of those types of conversions on the exam so you won't have to memorize them. But we're still not done yet, because the liter that we have with our conversion factor does not match up what we want to end with. And so we have to do one more conversion. So we know that 1 liter is equal to 1,000 centimeters cubed, which we also said was 1 mil. And so what we can start doing, and the way I start to check my answer, is to make sure that all of the units cancel out that need to cancel out. And so what we do is, if you see a unit on top and a unit and the same unit on bottom, those can be canceling out, just as if you were to divide them. So we can cancel out the gallons, we can cancel out the liters. So what we are left with is what we wanted at the end of the problem, centimeters cubed. So now we need to solve this problem. We're not done yet. So when you see two numbers next to each other in this railroad system, you multiply them together. And so in this case we have 3 numbers across the top, and so we will multiply all 3 numbers together. If we had a number greater than 1 on the bottom, so going this way, we would divide. That is why you are allowed to cancel out those units. And so when we solve this problem, we get a number of 18,925 centimeters cubed. In a couple slides, we'll talk about significant figures. And so one of the things that I want you to think about after you look at that slide is to come back to this question and to see if that answer would actually be correct with its numbers of significant figures. So, for Friday, what I want you guys to do is I want you to do problems number 91 and 103. and I want you guys to turn them in to the front of the class before class starts, but I also want you guys to show your work so that I can start to see how you guys solve these types of problems. Another thing we can do with the units we're covering is we can make what's known as derived units. Derived units are a mixture of two different types of units. The one that we are going to look at in this video is density. Density is usually a unit of mass divided by a unit of volume. So it's usually grams per liter. We can do a variety of different calculations with density. One of the things you will hear me talk about with a unit like density is it is what's known as a bridge unit. So density helps bridge between mass, how much something weighs, or the number that it says on a scale. It helps bridge that to volume, how much space it takes up. And so it can do that because it's in grams per liter. So let's look at an example. This comes from number 69 in your textbook. So, antifreeze. Besides being poisonous, it has a density of 1.11 grams per centimeters cubed. And remember, we said a centimeter cube is very similar to 1 mil. So, part A asks, what is the mass of 417 mils of antifreeze, or ethylene glycol? So let's set up our train tracks. So we are going to start with 417 mils. But what's our density in? Our density is in grams per centimeters cubed. So why don't we go ahead and convert mils to centimeters cubed? That will help us see how these units can cancel out. So we now have 1.11 grams per centimeters cubed. So we have 1.1. So we know for every 1.11 gram, we get 1 centimeters cubed. And what we end with is the mass, the grams, that we were looked for or asked to solve. And so now let's see if we've set this up correctly. Mils, centimeters cubed. So yep, we're left with grams. And so when we multiply across the top, we get 463 grams. Now, whenever you're presented with a derived unit or a unit that is made up of something divided by something else, if we were to do this, if you want to use this railroad method, the numerator always goes on top with the number. The denominator always goes on bottom with the number 1. And so we now have 1.11 grams per centimeters cubed is equal to 463. So if you're given a volume, you should be able to find a weight because of this unit. Let's look at part B of question number 69. So we want to know the volume in liters of 4.1 kilograms of antifreeze. So, like we always do, let's start with what we know. We know we have 4.1 kilograms. Let's look at our density, which was 1.11 grams per centimeters cubed. So, but we start with kilograms, so we're going to have to convert kilograms into grams. And so now we put in our density, and I will explain why we have to flip it after we go ahead and fill it all in. And we know that 1 centimeter cubed is 1 mil. But we wanted to solve for volume for liters, so that we know for 1 liter we have 1,000 mils. Now you might be asking, Dr. Bishop, why did you put the grams on the bottom and the centimeters cubed on top? And the reason I did that is so that we can cancel out that unit right there. So if one of the reasons why I solve problems like this is because it helps me see where all the units are and where they need to be canceled out. And so if we were to just keep it as is, so remember, top and bottom, they cancel out, they get divided. Everything gets crossed off, whoops, except for liters. So we're left with liters. That is what we want. Whenever you go from weight to volume, you divide by the density. Whenever you go from volume to weight, you multiply by the density. That's just the simple rule that you guys can learn. And so, remember, across the top we multiply, across the bottom we divide, and so you can see that these thousands will cancel each other out. And so when you solve this problem, you will get 3.7 liters of antifreeze. It's a lot of antifreeze. So again, for Friday, you can add this to the same page where you did your previous other problems. I want you to do number 70, A and B. Very similar problems to what I just showed you here. But again, the more practice we get, the better we'll get at solving these problems. So the final thing that we're going to talk about with regards to numbers is significant figures. Significant figures are very, very, very important. So we said most students lose points because no units. The rest of the students lose points because they don't have the correct number of significant figures. And so we'll talk about the rules of significant figures in class, but just for a problem that we'll work through, we'll look through number 83 and we'll look at both A and B. That's in the back of your book. So, A, we're given this problem. 9.15 divided by 4.970. So, the first thing we need to do when we're presented with a problem is to determine how many significant figures are in each of the numbers that are in the problem. All non-zero numbers are always significant. So this first number, 9.15, all three are non-zero, so we know they have three significant figures. Now, 4.970. Well, it has three non-zero numbers, so we know it has at least three. When you have a zero after a decimal point, so here's the decimal point, there's the zero after, it is always significant. So since that's always significant, we now have 4 significant figures. Here we are dividing one number from another. When we divide, the number that has the least significant figures in it sets how many your answer should have. So, let's say we do this problem, and so you punch it into your calculator, and let's say you get this readout. or something similar to it. This has how many significant figures? Well, 1, 2, 3, 4 non-zero numbers, so it has 4. But since we divided these two numbers together, we said the number with the least amount of significant figures tells us what the answer should be. So what we should do is we should round this 3 to a 4. And so now we have 3 significant figures which matches that number. The correct answer on an exam or a quiz would be 1.84. You will notice that I've put a box around the final answer. Go ahead and make that a habit of yours as you do your homework on paper or you do these extra questions that I'm having you do for class. Go ahead and put a box around your final answer because it helps us figure out where we're going and where we've been. So let's look at B. So we have 1.54 times 0.003060 times 0.69. So we should know how many significant figures this first number has, 1.54. It has 3 because of all 3 non-zero numbers. Let's look at the next number. So we know this 0 at the end is a significant because it's after the decimal point. We know the 2 non-zero numbers are significant, so there's 3. This 0, anytime you have a 0 in between 2 non-zero numbers, it is always significant. So now we're at 4. But what about these zeros? Leading zeros, the zeros that are either before a decimal point or directly after it, are never significant. So these 3 zeros are never significant. All they do is tell us where that decimal place is. So we only have 4 significant figures in this number. So if that's the rule for the second number, then the third number, this 0 isn't significant, and so we only have 2 significant figures. So based on what I told you before, the final number of significant figures after we calculate it should be 2. And so if we multiply all these together, you get 0.033. So what I want you to do again for Friday, I want you to turn in all of these problems I'm having you do Friday before class on the front table. I want you to do C and D of number 83 in the back of your book. So one of the things that we've been working through as we started these simple problems is that there are different strategies can be used. And one of the things that we'll constantly work through as we go through these problems is how do we solve the problems? And so the first thing I said is always know what you start with. If you already know what you start with, then you know where to begin. Then you need to know where to end. What I mean by that is the unit you want your final answer to be in. And then what comes after that is the path to get there. And what we will do in this class, and what I'm trying to put forth with these videos, is to help us start to do these 3 steps on a consistent basis and to practice them. Because with practice makes perfect.